Take a deep breath in and let it out. Welcome to your deep focus space. Settle in, clear your mind, and let's dial that internal focus level all the way up to 100%. Today, we are calmly and systematically securing top marks in Cambridge AS and A-level mathematics. Specifically, we are diving into Syllabus Section 1.7, Differentiation. Over the course of this explainer, we're going to break down the gradient as a limit and map out the exact pathways for first and second derivatives. Our goal today is simple. We are going to completely eliminate your exam anxiety by replacing it with pure, highly calculated strategy.
Now, you might be wondering why we are isolating this one specific topic. Well, as senior examiners consistently highlight, mastering differentiation isn't just about passing your paper. It is literally the absolute dividing line between a solid B and an elite A-star execution. The stakes here are undeniably high, but I want to reassure you, the path to getting that A-star is incredibly predictable. Once you know exactly what the examiners are looking for, the anxiety just melts away. You're left with a clear, serene sense of mathematical purpose.
Here is our strategic roadmap for this session. First, the core principles. Second, the technical procedural framework. Third, critical evaluative analysis. And finally, top principal examiner warnings.
Section 1. The core principles. Let's ground our theoretical architecture.
Differentiation isn't just moving numbers around a page. At its absolute core, it is about understanding the gradient as a limit. Now, the syllabus explicitly states that the assessment of this topic targets 4 distinct cognitive domains: knowledge, understanding, application, and analysis. To truly master this, I want you to imagine 2 top-tier scholars working through this exact material in a shared digital workspace. Let's call them Alex and Sam. Alex is incredibly analytical, highly precise, but sometimes crowds the page with unstructured facts. Sam is highly creative and dynamic, but occasionally loses focus on the specific command work parameters. As they look at a high-tariff question, they practice the zen of decoding command words. They calmly peel back all the filler text, isolating the exact assessment objectives demanded by Cambridge. They pause and ask, is this asking us to simply analyze the derivative or evaluate its impact on the larger function? What top-performing students do differently is they exhibit a deeply connected conceptual understanding. They don't just memorize the rules, they understand the why, which makes their knowledge instantly transferable to completely unfamiliar contexts.
Building this strong theoretical architecture means your foundation rests on 3 vital pillars: precise definitions, understanding causal relationships, and seamlessly integrating this with other syllabus areas. Let's look back at our scholars. Alex meticulously maps out the textbook definitions step by step, ensuring total accuracy. But Sam brilliantly steps in to challenge the framework, reminding Alex to include a clear, logical, evaluative link. Cambridge Principal Examiner reports consistently highlight that candidates who reference cross-topic connections, for instance seeing exactly how differentiation perfectly aligns with coordinate geometry or kinematics, are the ones who achieve significantly higher marks. It proves you aren't just reciting a formula. It proves a holistic, serene mastery of the entire mathematical landscape.
Section 2. Technical Procedural Framework. Let's transition to the method mark strategy.
When you sit down and face a complex, high-tariff differentiation problem, you need a flawless, chronological recipe to confidently capture every single process mark without hesitation. Step 1. Deconstruct the question. Find exactly what those command words are demanding. Step 2. Extract the relevant data from the text, filtering out the noise. Step 3. Select the proper analytical framework. Step 4. Execute your mathematical steps with perfectly clear notation. And Step 5, present your final answer with pristine, correct terminology. Imagine Alex and Sam debating this very layout. Alex wants to rush the calculation, but Sam calmly says, wait, if we don't extract the right parameters first, the execution falls apart. They challenge each other smoothly, assembling a flawless response line by line. Following this exact flow ensures that even if you make a tiny human arithmetic error at the very end, your method marks are cleanly, beautifully, securely captured in the examiner's net.
But listen, execution is really only half the battle. Presentation is the other. Before we write out our final top-band paragraph structure, let's breathe and refocus. Make sure your daily study dashboard is complete, subscribe to Ace the Exams right now, and enable all notification alerts. Whether your target is an IGCSE, an O-level, or an AS and A-level A-star, this channel is your weekly space for stress-free exam mastery. Okay, focus back in. Sometimes you'll hit a structural roadblock mid-paragraph where your mathematical evidence drops out of alignment. This is where the Peel structure comes in. Point, evidence, explanation, link. It restores complete balance to your text. The syllabus stresses that practical application develops essential professional skills. Examiners are actively looking for strict presentation conventions, proper headings, correct terminology, like clearly distinguishing between dy by dx and the second derivative, clear annotations. These choices signal to the examiner that you are a highly disciplined, top-tier candidate.
Section 3. Critical Evaluative Analysis. Let's look through the examiner's lens.
Welcome to the practice arena. Here is the absolute dividing line between an average paper and a brilliant one. Let's try what we call the mindful scan. Imagine a highly complex Cambridge source text in front of you. You have a 60-second mental countdown. Can you extract the single most high-yielding core trend? A generic, standard approach will just be purely descriptive and completely lack a link to the specific scenario. That's what we call the imperfect answer. It's up to you to identify exactly where the structural discipline breaks down. An A-star candidate's approach, however, is highly context-specific. It evaluates the mathematical alternatives and justifies every single step with clear evidence from the prompt. Examiners explicitly state that the absolute classic mistake is providing generic answers. If you are calculating a rate of change for a real-world model, your derivative actually means something specific to that model.
To ascend into those elite top bands, you must seamlessly demonstrate evaluative thinking. This means calmly questioning assumptions provided in the text. It means considering different mathematical perspectives, and most critically, justifying your decisions with concrete mathematical evidence. When the question demands it, you must evaluate alternatives and logically draw conclusions about relative importance based strictly on your first and second derivatives. Is it a maximum? Is it a minimum point of inflection? Why? You can't just state it, you have to provide the comparative analysis and deeply support it. This is where Sam's big picture logic perfectly aligns with Alex's precision.
Section 4. Top Principal Examiner Warnings. Let's navigate the pitfalls to avoid.
Warning number 1. Examiners frequently report that students, when under pressure, confuse cause and effect in differentiation. Remember those crucial causal relationships we discussed back in the theoretical architecture? If the second derivative is negative, that fundamentally causes the turning point to be a maximum. Do not let the exam hall adrenaline get this relationship backward in your final concluding statements. Cognitive clarity here is absolutely non-negotiable.
Warning number 2. Forgetting to check your format and presentation. This is truly where candidates needlessly bleed away vital process marks. You've sat there, you've done the heavy cognitive lifting of finding the limit or calculating the complex derivative, but then you casually drop your notation halfway down the page. The examiner simply cannot award marks for steps they cannot clearly read or logically track. You have to maintain your serene discipline all the way down to the final double underline of your answer.
Warning number 3. Answers are not specific to the context given. As we highlighted earlier during our mindful scan, this is the loudest, most persistent examiner alert year after year. You might perfectly calculate the first and second derivatives. The algebra might be flawless, but if the question asks what this means for the velocity of a particle, and you just casually write x equals 4 as a minimum, you have entirely failed to link your mathematical point to the specific scenario. You must always tie the pure math back to the physical reality of the question.
Final recap and memory hack. Let's lock in and secure that A-star.
To keep your method perfectly on track in the exam hall, I want you to use a very simple, very calming memory hack. DESEP. Deconstruct, extract, select, execute, present. When you first sit down, lightly write this acronym at the top of your paper when starting any 10-mark differentiation question. Let it guide you. It powers the 3 core focus pillars we use to dominate these papers: the 3-step question scan for decoding, the marks per minute flow formula for timing your execution, and the final polish review pass for your presentation.
So, to synthesize this entire explainer cleanly, here are your 3 vital takeaways. Number 1. Master your cross-topic conceptual connections. You have to know exactly how differentiation breathes and lives within the wider world of mathematics. Number 2, always employ that 5-step procedural framework, DESEP, to absolutely guarantee you capture every single method mark. And number 3, always, without fail, link your final analytical points back to the specific context given in the exam prompt.
I want to leave you with this final, provocative thought. As you look at your completed, flawless response paragraphs, ask yourself, are my differentiation steps mechanically sound but contextually disconnected? Fixing that final layer of disconnect is your absolute last step to true exam mastery. Thank you for joining this deep focus explainer. Make sure you are subscribed to Ace the Exams, click that notification bell for future focus deployments, and leave a comment down below right now identifying your specific subject, your tier, and the exact target grade you are currently meditating on. Keep practicing, stay calm, and I will see you in the next one.